Hi student, today we are going to discuss about metal deficiency defect. Metal deficiency defect, it is a non-stoichiometric defect. Non-stoichiometric defect. What is non-stoichiometric defect? The defect in which the ratio of the cation to anion does not remain same before and after the defect is called a non-stoichiometric defect. So what is non-stoichiometric defect? The defect in which the ratio of the cation to anion does not remain same. The defect in which the ratio of cation to anion does not remain same before and after the defect is called a non-stoichiometric defect. So the metal deficiency defect arises due to the presence of less number of cation than anion. Here the cation is present in less number than anion. So this type of defect observed in crystal in which the cation have variable oxidation state. The cation have variable oxidation state. For example, so we are taking iron oxide crystals. Iron oxide crystals. Here we are taking the iron oxide crystal. FeO crystal. So in these crystals, so before the defect, we can calculate the number of cation and anions. So what is metal deficiency defect? So the metal deficiency defect arises due to the less number of cation than anion. So the presence of less number of cation than anion. So in this FeO crystal, now let us calculate the number of cation and anion before the defect. Before the defect is the before defect. Here the number of Fe2 plus ions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ions, 10 Fe2 plus ions. Then charge 10 twos are 20 plus charges, and O2 minus ion 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. O2 minus ion also 10 ions, 10 twos are 20 charges. Here the net charge is 0. Before the defect, the number of the cation and anion are equal. So after the defect, after the defect one Fe2 plus ion is missing from the crystal lattice. One Fe2 plus ion is missing from the crystal lattice. One Fe2 plus ion is missing from the crystal lattice. Now let us calculate the number of cation and anion after the defect. Fe2 plus ions, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fe2 plus ion 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here 9 ions. 9 Fe2 plus ion, charge 18 plus, and O2 minus ion 10, charge 20 minus ion. Here net charge 2 minus ions extra is present after the defect. After the defect, so in order to maintain the electrical neutrality, so the nearing Ne2 Fe2 plus ion get oxidized to Fe3 plus ions. Here the neighboring Fe2 plus ion get oxidized to Fe3 plus ions for maintaining the electrical neutrality. For one missing Fe2 plus ions, two neighboring Fe2 plus ion get oxidized to Fe3 plus ion for maintaining the electrical neutrality. So this such a type of defect is called a metal deficiency defect. So the metal deficiency defect arises due to the presence of less number of cation than anion. This defect observed in the metal having the variable oxidation state. The metal having variable oxidation states shows such a type of defect. Okay. The metal deficiency defect arises due to the presence of less number of cations. So metal with a variable oxidation state shows this defect. So in order to maintain the electrical neutrality, twice the number of missed Fe2 plus ion get oxidized to Fe3 plus ion. So for example, we are taking iron oxide. In iron oxide, so in FeO crystal, some of the Fe2 plus ion missing from the crystal, that is, to maintain the electrical neutrality, twice the number of Fe2 plus ions in the crystal is oxidized to Fe3 plus ion. In such a cases, the overall number of Fe2 plus ion and Fe3 plus ion is less than the O2 minus ions. Here, the overall, the cation and anion, we can calculate the cation and anions, which is less than the O2 minus ion. Here, Fe2 plus ions Fe2 plus ion is 9. Okay, Fe2 plus ion less than the O2 minus ion. Here Fe3 plus ion is also less than O2 minus ion. Okay, Fe2 plus 9 ions present here, and Fe3 plus ion is also 2 ions are present. Okay, so the overall number of Fe2 plus ions and Fe3 plus ions is less than the O2 minus ion. So it was experimentally found that the general formula of ferrous oxide is FeXO. We can write FeXO. The general formula of ferrous oxide we can write after the defect FeXO. Here the O ranges from where the X ranges from values 0.93 to 0.98. So this is the metal deficiency defect. So metal deficiency defect is a non-stoichiometric defect which arises due to the presence of less number of cation than anion. Okay, the metals which has a variable oxidation state shows this metal deficiency defect. So I hope you understand, student. Thank you.